Hello everyone, welcome to part 2, which is intermediate exercises of this OpenCV tutorial series. And we are going to look into lesson number 1, which is color detection. The first thing you want to do is come on to the top of the earliest thing, and come here where it says the cloning the repository and also changing the directory. Let's run this function by itself, and we are only interested in this just because we do need this OpenCV tutorial folder, and it has certain images, and we're going to be using one of these images here for our project. So let's come down here and let's look into the intermediate exercises, and we are under color detection. The first thing you want to do is import all the libraries that we need, and we will need import CV2. We also need NumPy as NP. Let me maximize this a little bit so it's easy to read. So import NumPy as NP. We are also going to be importing the Google Colab library for our display. We'll say from google.colab.patches import cv2 underscore imshow. Let me show you what I've done here. So from Google Colab patches, we are importing cv2 underscore imshow. Now we have all these images. We have everything in our folder. If you go back to this directory and under the OpenCV tutorial folder, under the images, you have certain images, and we are going to be using this image called shapes.png. So coming back here, we will say, okay, OpenCV, you know what? I have this image called shapes.png, and I want you to read it. For OpenCV to read this image, we use OpenCV cv2.imread. So OpenCV will tell me, okay, I'm going to use imread to read, but give me the file name. What's the file name? Okay, the file name is going to be shapes.png. But this shapes.png is inside the folder called images. So I will also need to provide the folder path, which is images with a slash. So images slash shapes.png is where the image is available for us. Okay, so that will read the image and it will save the image under the image folder variable. Now let's display this image by using cv2 underscore imshow image. And we just display this image here for us. So we're just reading and displaying the image. Okay, good. Let's run this, and we can see that it is displaying this set of image. It's a big image and which has all the shapes and different colors present in here. Okay, good. Now coming back to the code. So we have the image right now and we are just displaying it. Now say if I was only interested in particular colors. I have this blue color here. Let's say that I'm only interested in this blue color for now. Okay, so we come here. The easiest way to select blue color is to first convert it into a HSV image instead of a BGR image. Currently, image is a BGR image. It is represented in blue, green, and red channels. Okay. Now we want to convert this image into a HSV image. So we have, okay, coming here, let's come down here. Let's convert this into an HSV image, and we'll call it HSV image equal to CV2 convert color. We used this function in, I believe it was lesson number 2. It was right here in the lesson number 1, I believe. Yes. It's changing the color profiles. We used it here for our convert color, BGR to gray, BGR to HSV. If you haven't watched that part, go back to the page where it displays the HSV image. We have given a description of what HSV images are and how do they look like. Now, coming back to the color detection aspect, coming here, we are just using the convert color function to convert our BGR image to a HSV image. And this convert color function requires us to tell what's the original image. The original image is the image variable right here, and we specify the image. After that, we do need to provide what kind of a conversion you're doing. Now, since we're going to be using BGR to HSV, we're just going to say convert color BGR to gray. So we have BGR to HSV, I'm sorry, BGR to HSV. So this function right here, HSV, is going to be converting a BGR image to a HSV image. Now we have the HSV image. Do you want to see the HSV image? If you have watched the previous video, you don't want to do it, but just for the sake of understanding, let's run this. There seems to be a function error. Yes, because we used the underscore. We did not use the underscore, instead we used the dot version. So you can now see that this HSV image is different. It's different to what's available here. This original image has different colors for the different shapes, but here it's almost the same, but it's not the same. Mind you on that. It's a little bit different. Yes, it is in yellow in color, but they have different color profiles, different ranges. And we'll see how we can utilize that factor. Okay, let's remove this. Let's just play this. So we have our color image here. Okay, now what is the next step? The purpose of HSV is because you are converting a BGR, a 3-channel image, into a HSV image where hue, saturation, and variance, hue represents the color profiles. So you can now control the value of hue to display what color you want. So I will say, okay, I have this image, it has different colors, and I'm only interested in this blue color. So I can isolate this blue color in the HSV range by saying, okay, my lower blue color, so you need to provide a range of your blue color values. And I'm going to say, okay, my lower blue color, it's under the array, it's going to be an array, and this blue color array is going to have a value of, say, 65, 0, and 0. And I'm going to supply another upper range. Now stay with me on this and I'll explain you what's happening here. And I'm specifying another array, and this array is going to have a value upper bound of 110, 255, 255. So I'm having two upper array. So I have a lower bound and an upper bound. And I use this lower and upper bound to take out or extract just the blue color. Basically what I'm saying here is, okay, I have an image and I'm only interested in the blue color, which is between these two values, lower blue and upper blue. And this lower blue is specified by the hue value between 65 and 110. So my blue color is between 65 and 110, and the rest, the saturation and the variance, is maybe between 0 to 255. I don't care. Right now, I'm only interested in my hue value, which specifies the color, and my color, which is the blue color, is between 65 to 110. And this is what OpenCV will look for. Anywhere where blue color or the hue value is between 65 and 110, it will extract that and ignore the rest. Basically, the value of this color can go anywhere from 0 to 255, 0 to 180, but we are only interested in 65 to 110. Okay, so we have defined the boundaries of our blue color. Now we are going to be using a range function to create a mask. Okay, I am creating a new mask. Now this mask is going to have the value only of the blue color. So OpenCV has this function called inRange. InRange, and this range can take these lower and upper bound range and return the pixels that lie between these ranges, this range. So I say CV2 inRange and you want to find the range between in the HSV image using the lower bound and the upper bound. You can see the source image, the lower bound, and the upper bound. Coming back, we supplied the image, which is the HSV. We are now supplying the lower bound, which is lower blue, and we are also supplying the upper bound, which is the upper blue. And it will create the mask for us. Let's generate this, and we can see how the mask looks like. It'll be a black and white image, which will only consist of blue color. So you can see that this is the original image right from here in the bottom, but the upper image only is specifying the triangle which represented the blue color original. So it's now creating that mask is created where it's only representing the triangle. Now, so let's not display the IM show original image so we don't get confused. We can see the image now only is creating a mask around the blue color rectangle. Okay, so good. Now the next step is to use this mask to extract the original blue color from the previous image. So we can use a bitwise operation on this. We can say, hey, result equal to CV2 bitwise. Oh, did I move out of it? Yeah. Now I hope it's visible now. So we have bitwise and wherever your mask has an image, wherever your mask is white in color, like this case, wherever the mask is white color, it should return the original color of the image, and wherever it is black, it should just ignore that. That's what the bitwise AND is going to do. Wherever white color is present, it will give out the original color, and wherever it's black, it will ignore that area. So we'll say, okay, you're going to be doing bitwise AND on my image, and you're also going to return the image in my same image folder, and we are going to use a mask which is given by our variable here, mask. So this is my function, and we have defined the result image. Now let's display this result image. Okay, so we are displaying this result image now. Let's run this. And let's minimize this a little bit so we can see. So you can see the original mask looks like this, and the final image looks like this, where it has extracted the original part of the image. It has the blue color. Similarly, if you were interested in the different types of colors, you need to specify the different lower and upper range values. So like we did lower blue here, instead of blue, we can say lower hue and upper hue, because we are actually converting, or we are actually using or playing with the hue values. So we'll say upper hue and lower hue. So let's run this back again to make sure our code is fine. We did not break anything. Yes, everything seems to be working fine. And we also don't need to display the mask anymore, since we know how the mask looks like. Basically a black and white image, and you can see that this image is only representing the blue color rectangle. Similarly, our original image had different other colors, like it had the red color, the yellow color, and we'll see how we can extract the different colors. With this lower and upper bound range, we find the blue color triangle. Now, similarly, there are different other color profiles, which can represent different other colors that you might be interested in. So similarly, like we have blue, we have the red color. Red color, and you can use the red color by using our lower hue, and our lower hue is equal to, again with the np.array, and this array is going to have a range of values between 0 to 20. So because this red color is basically 0 by 0, it's in the original spectrum of, it's in the initial spectrum of the hue value. Similarly, we are also specifying upper hue, equal to np.array, and this function goes from 0 to 20. U is between 0 to 20, and our saturation and variance, we don't care. It can be anywhere between 0 to 255. Once we have this, let's comment this so it doesn't affect our original part. So we have the blue, and now we're looking into the red color. So let's run this, and you can see now that it's only showing the red color circle. So it's extracting, it's only isolating the red color from the original image. Similarly, there are different other profiles. So we had the red color. Now we can also look into green colors. Now green color also has its own lower and upper hue, which is given by np.array, and this function of green color goes from 46 to 91. Now you might ask, how am I getting these values? How do I know that red color is between 0 to 20? Well, how is blue color between 65 to 110? Similarly, how is the upper range of green color between 46 to 91? This is more with trial and error. And again, OpenCV also has a function called track bar. Now I'll show you what it looks like. CV2 track bar. And this track bar, it's something which cannot run on a Colab, but you can also run it on a standalone desktop application. So this track bar basically creates this kind of a range track bar, and you can change the values of your color, the red, the green, and the blue, and you can see what kind of an output you're getting. And that output, then you can take that and then represent it in your own code. So you know what the upper and the lower bound limits are. Using this track bar, you can always play with it. It's something which is not too complicated to work with. We will see it in the later future projects if we ever get to use it. But if in case you're interested in identifying what kind of upper and lower bounds are, you can always use a track bar to run with it. So looking into green color is between 91, and we are again not interested in the saturation and variance values. We have, let's comment the red color now, and let's run this just for the green color. So you can now see its green color is being displayed very nicely. Now, say if I were to display all the three colors, or maybe red color and green color together, you know the red color starts from 0 and ends at 20, and the green color, on the other hand, starts from 46 and goes till 91. So if I were to say, okay, instead of 46, let's put 0, it should give us both the red and the green color, and maybe some other colors also. Yes, you can see that it can give out the red color, the green, and also the colors between both of them. So you're getting this color also. Let's change this back again to where we were. So we have 46 to 91. Now let's come back and now try to discuss or identify where the yellow color is. Now again, lower blue, lower hue, which is given by an NP array, and this array, this is a NumPy array, and you're defining this NumPy array between 21, 0 for saturation, 0 for variance, and you also have an upper hue and NP array, which has 21 to 45 and 0, oh no, 255 and 255. So you can see it's ending up at 45 and then starting at 46 for green color. That's the reason you had both when you try to represent between 0 to 91. So you were getting yellow color as well. Okay, let's comment this and let's run this. And this yellow color is now being extracted or isolated. So you can see, again, if I were to change instead of the 21, if I were to put down 0, it would give us the value of all the three colors, which is the green, the red, yellow, and the green. Now, why is the green missing? Because the upper bound is 45, whereas the green color is starting at 46. So if we were to say, okay, instead of 0 to 45, let's say 0 to 91. And if we were to display this, you can see that it's also giving all the three colors. What if we needed the blue color as well? So again, you can play this value. You can see that the blue color starts at 65 and ends at 110. So if we were to change the upper bound limit to 110, and if you just run this, it should include all the four colors that we wanted. So any color that you're playing with, any color that you're interested in your own images will lie between that range, 0 to 180. So identify whatever color you are interested in and then work accordingly. Okay, let's convert this back again to what we wanted. So we needed the yellow color, and the yellow color is between 21 and 45. So if we just needed the yellow color, let's run this, and you can see that it's only giving us the yellow color.